Good afternoon, guys. Um, so today I'm going to be looking at the solutions to two questions from the January 2021 paper, right? And this is CSEC Chemistry we're talking about here. So for those of you who don't know who I am, my name is Terry David, right? I have several popular channels on YouTube. If you all want additional help in CSEC Chemistry, just go to YouTube, search for CSEC Chemistry, and I will come up there. Right? I'm an electrical and computer engineer. I'm also a past national scholarship winner, right? I got the highest mark in A-level chemistry a long time ago, right? At that time we did Cambridge exams, not CAPE, right? I'm also the author of the official study guides for CAPE Physics Unit 1 and Unit 2, and you may have seen some other books out there as well, right? So this question that I'm going to be looking at, right, has to do with organic chemistry. Now, a lot of students, they're afraid of organic chemistry, right? Talking from my personal experience, organic chemistry is the easiest topic in the whole of chemistry, right? They can only ask the question so many different ways, right? It's not a difficult topic, right? Between now, that is, we're in February, so between February and May, June, all I'm going to be doing with my online classes are examination questions, right? So those of you interested in joining my online chemistry class, right? My contact is 868, so it's 868-784-2059, right? You can always send me a WhatsApp, right? If you're interested. The chemistry classes are held on a Saturday, right? Now let's look at this. So this is January 2021 paper that came, I think, last week or week before, right? So the first thing they told us, we have a compound 2-methyl-butane and pentane are structural isomers with molecular formula C5H12, right? So that's the formula of these two compounds here. Now they said they are structural isomers, right? Now in chemistry, organic chemistry, there are different types of isomerism, right? But the one you guys need to know for CSEC is structural isomerism, right? Now structural isomers, all right, are isomers that have the same molecular formula but different structural formula, right? So this is what we're going to say. We're going to say compounds, right, which have the same molecular formula but different structural formula, right? So that's the key thing here. They have different structures. Right? So that's your answer there for 2 marks. That's it. Right? Now they want us to draw the structure of 2-methyl-butane. Right? Now look at the formula. The formula is C5H12. Right? So, and it's 2-methyl. Right? Now just based on the name alone, I'm able to figure that out. So 2-methyl, right? Butane. So butane is my longest carbon chain. Now but means I have 4 carbon atoms. So I've drawn a chain that has 4 carbon atoms here. And my methyl, right? The methyl part of it is bonded to my second carbon. That's what this is telling me here, right? And the methyl group is actually the CH3 group. So this here tells me that that is CH3. The fact that I have butane here tells me that I have 4 carbon atoms, right? And that's what I'm going to use to be able to draw this. So my structure here is going to look something like this. So just remember, every carbon atom must only have 4 bonds around them. So this here is going to be the structure right? So this is a branch hydrocarbon, right? And it's 2-methyl-butane, right? So you're getting 2 marks just for this, right? So that's why I said organic chemistry is not that hard, right? But you can get marks easily in the exam. And the thing is that there are usually 2 questions on organic chemistry in your exam paper, right? Now, the next thing they want us to do is draw and name one other structural isomerism with C5H12, right? Now, they already gave us 2. They said one is 2-methyl butane and the other one is pentane, right? So we have to draw a third one. The pentane will be the straight chain, right? The one that has 5 carbons in a row. So for this other one here, what we're going to draw, right? We're going to draw a structure that looks like this. So it's going to be, so you're trying to draw a structure that looks different to what we just drew, right? So remember, each carbon must have 4 carbons bonded to it, right? So what I've done here, let's see, you make sure we have 5 carbon atoms. We have 1 here, 2 here, 3 here, right? Now, they told us to draw it as well as name it, right? So you need to be careful. When you are naming your hydrocarbons, right, what you will do is identify your longest carbon chain, in which case it's this. This is my longest carbon chain here, right? So this is my longest carbon chain. Then we're going to have to number those carbons, right? So I'm going to call this carbon 1, carbon 2, and carbon 3, right? Now, in terms of naming now, you realize, wait a minute, on this second carbon here, you have 2 branches. You have this here, and you have this here, right? So when it comes to naming that, right, it's going to be 2, right? Now you have 2 methyl groups, right? This here is a methyl group, right? This is also another methyl group, right? So this formula, or the name of this compound, will be 2, 2, right? Because you have 2 branches on this carbon atom. Now it's 2 methyl groups, right? So what we are actually going to say is dimethyl, right? So we're going to say di, methyl, dimethyl. And our longest carbon chain was 3 carbons long, right? So that's meet, eat, prop. If you have 3 carbon atoms, it's going to be propene, right? So that's the name of this compound. So this is the answer that they're looking for in this question, right? So it's 2,2-dimethyl propene, right? So that's the other structural isomer for C5H12, all right? Now, let's look at this next one here. So this part B. They said ethanol can undergo various reactions, and depending on the reagents and conditions of the reaction, right, products with different functional groups are formed. So we're talking about, this question is based on the reactions of ethanol, right? Now, the first part of the question here, what is the functional group present in ethanol? Now, this is my formula, right? So they were kind enough to give you the formula. So if I were to draw this, just for you guys to see what we're talking about here, right? This here is my ethanol, right? Now, our functional group that is present in my ethanol is this group here, that OH group. So the name of that group, right, it's called the hydroxyl group. Hydroxyl group. So that's the name of my functional group. That's the answer that they're looking for here, right? Or you could have just written down this ROH as your answer, and that'll be correct as well, right? So the functional group there is the hydroxyl group. Now, the second part now here, they said table 2 summarizes conditions and products of 2 reactions of ethanol. Complete the table, right, by inserting the conditions. So when it comes to organic chemistry, you guys need to know the conditions for different types of reactions. And they want us to draw the fully displayed structure of the products which would be formed, right? Take note that the type of product to be formed is given in the table. So if we look at the first row, and by the way, look how much marks you're getting for this, eh? This is 2 marks here, another mark here, so that's 3 marks, and 2 5, and 2 7. So that's 7 marks. So if you knew your organic chemistry, this would be a very easy question in the exam, right? Now, here's what we're trying to do. You're starting off with what we're starting off with here with, we're starting off with ethanol, right? So you're starting off with ethanol and you want to get an alkene, right? So if you want to convert an alcohol into an alkene, right, that's a dehydration reaction, right? What you're doing in that reaction is you are removing your water, right? That's what you're doing there in when you convert from an alcohol into an alkene, right? So you need to remember your conditions, guys, right? Now, here's what we need to do. Our condition for this particular reaction will be excess, right? Our conditions for this reaction is excess, right? Concentrated, you need to put this, concentrated sulfuric acid, right? So it's concentrated sulfuric acid, right? And we have a temperature for this as well. Our temperature in this case will be 170 degrees Celsius. So you guys need to know these temperatures. So what CXC will do is probably give you 1 mark for saying excess concentrated sulfuric acid and another mark for my temperature, which is 170 degrees Celsius, right? And they want us to draw the product. You started off with ethanol. So therefore my product should be ethene, right? This here is my product that I'm going to get, right? So when ethanol is dehydrated, this is going to be my product. And 1 mark for doing that, right? Now, the next part here now, you want to produce, they tell us that the product we're going to get here is an ester, right? And one of our reagents in this particular case here is ethanoic acid. So this here is ethanoic acid, right? Now, when you react ethanoic acid, right, or you react an organic acid with an alcohol, you're going to get an ester, right? So therefore, my conditions for that reaction there, right, and that process, by the way, is called esterification, right? And my condition here that we're going to use, right, will be concentrated sulfuric acid, and we're going to heat under reflux, right? That's my condition if I want to produce an ester. So we're using concentrated sulfuric acid again, conc H2SO4, and we are going to heat under reflux, right? So that's my conditions here in order to convert or to produce an ester. Now, the next thing they want here for 2 marks is to draw the ester. Now, you need to be careful when you're drawing these esters, right? Now, typically what I tell my students to do is to draw the acid part first, right? So what we will do, we'll draw our acid, which is ethanoic acid, and that looks like this. Right? This is what ethanoic acid is going to look like, right? But it's combining with my ethanol to produce an ester. So then what we're going to do, we're going to do this, right? This is from the alcohol part of it. So this is my ester. In this particular case, my ester here is called ethyl ethanoate, right? So this is what my product is going to be, right? So this, as you realize, this is question 2, and it's a very short question. If you knew your work, right, you will be able to get full marks in this question, right? So this is question 2. Typically in the exam, question 2 and question 4 are what we get, right? Now let's look at this other question here, which is question 4. Now in question 4, what they did, they gave you a compound, right? And they give you certain reactions. So they give you a diagram and they show you different reactions that are taking place. Now, what they want here in, right, so the first part of the question, they want to know, identify the reactions 1, 2, 3, and 4. And you get a mark for each one. So in reaction 1, you need to go to the diagram. This compound A here, because I have a double bond present, this here is an alkene, right? That's what that is. That's an alkene because of the double bond. Now, when we go from an alkene, this compound B here, is actually an alkene, right? The double bond disappears, right? So for that particular reaction, right, what we are doing is adding hydrogen across the double bond. So this reaction here is called an addition reaction, right? It's an addition reaction, but because we are adding hydrogen, right, we also can call it hydrogenation. So you can say it's an addition reaction, right? But it's a special type of addition reaction, and it's called hydrogenation because you're adding hydrogen across the double bond, right? So it's an addition reaction, but it's a special type because we are adding hydrogen. It's called a hydrogenation reaction. So reaction 2 now. What's happening in reaction 2? So we have an alkene, right? And what we are producing here is what we call a halogenoalkene. That's what we get in here, right? Now, what is happening here is that bromine is adding across the double bond. So what we can say here, this again, it's an addition reaction, right? That's an addition reaction again. So alkenes undergo addition reaction. In my third reaction, let's see what's happening. Where is my third reaction? So my third reaction is this. I am going from an alkene and I'm producing carbon dioxide and water. So what is happening there? That's a combustion reaction. So that's a combustion, right? That's what that is, combustion, right? Let's look at reaction 4 now. In reaction 4, you are going from compound A, which is an alkene, into compound D. This compound here, the way how they've drawn it for us is a polyalkene. It's a polyalkene. Oh, sorry, one second. It's a polyalkene, right? Or we can say it's a polymer that is being produced. So this is a polymer, right? So the name of this reaction here is polymerization. So this is polymerization, right? That's the type of reaction taking place. It's a polymerization reaction. So look at that. You're getting 4 marks just for naming the reactions, you know. Let's move on and see what else we have to do here. So in part B now, they said identify suitable reagents and reaction conditions. Now that is the important part about organic chemistry. It requires you to know all your reagents and your conditions. And you want to know, right, so you want to convert, let's say in part 1, compound A to compound B via reaction 1. So it's compound, one second, let me just see, compound A to B. Right, so A to B, we're going from an alkene to an alkene, right? Now, like I said, that's an addition reaction, right? And we have certain conditions that we use for that, right? So in this case here, let's see, what do we need to give for that answer? Right, so they want the reagents. So the reagent that we need hydrogen gas, right? So that's my reagent. My conditions now, we need to use a nickel catalyst, so an Ni catalyst, right? We need a nickel catalyst, and we also need a temperature, right, about 150 degrees Celsius, right? So that's my temperature. So nickel catalyst, 150 degrees Celsius, right? So this here, the hydrogen is my reagent, and these are my conditions in order to be able to do that. So you're getting 2 marks for that. The next part, part 2, you want to convert from compound A to compound C via reaction 2. So compound A, where is compound A? So we start with the alkene again here to compound C, right? So what you are doing, you realize, wait a minute, I'm just adding bromine across the double bond, right? So therefore, my reagent, right, should be bromine, right? So we can just say my reagent is Br2, right? You could have said bromine in water as 1. So bromine in water, right? That's one thing you could have said, right? Or you can say bromine in tetrachloromethane, right? That's another way we can do this reaction, right? So bromine in CCl4, right? So any one of these here could have been my reagent, right? And in terms of my condition now this reaction can take place at room temperature and you don't require any special lighting. So the condition could be room temperature, right? No UV light required. Right? So this is what we are looking for here for part 2, right? Now let's look at part C now. They said in part C, given that R is the ethyl group, state the molecular formula for compound A. Now this is what compound A looked like. So A was, let's go back to my diagram, right? So this is what they gave us compound A as, right? Now that R group, right, they said it's an ethyl group. So the question is requiring us to know what is an ethyl group. So an ethyl group is actually a group that has 2 carbons in it, right? The word ETH tells me I have 2 carbons. So when they tell us it's an ethyl group, this is what my ethyl group looks like, right? So this here is my ethyl group, right? That's what it is. So they want to know what is the molecular formula of this compound, right? So all you have to do now to draw this compound, right? So it looks like this. I'm going to replace the R and put what my ethyl group is. Right? That's all I'm doing. Just replacing this H. That's it. That's all I'm doing. Right? Now, when we look at that now, we can easily state what the formula is. So the formula, if we look at that compound, it has 4 carbon atoms. 1, 2, 3, 4 carbon atoms. And we have a total of 2, 4, 5, 6, 7, 8 of 8 hydrogen atoms. Right? So they wanted to know what is the molecular formula for A. That's what it is. It is C4H8. And then the last part now, hence write a balance equation for reaction 3. What is reaction? Okay. So reaction 3 here is my combustion, right? So all we're going to do, we're going to say C4H8, right, plus oxygen, because it's a combustion reaction. And I'm going to get carbon dioxide, that's CO2 gas, plus H2O, right? Now, let's see if you can balance this now. You have 2 carbons on the left, so let's put a 2 here, right? Sorry, not 2. Let's put 4 here. 1 sec. Yeah, you have 4 carbons here, so therefore I need to put 4 in front of the CO2, right? You have 8 hydrogen here, right? So therefore I need to put 4 hydrogen here as well. Now let's see if you can balance the amount of oxygen. On the right hand side you have 4 2s are 8 oxygen plus 4, that gives me 12. So therefore this here should be a 6, right? Because the question asks for a balanced equation. So even though you put the products as carbon dioxide and water, you still need to balance this equation, right? And just like that, we've done 2 questions in the January 2021 exam, right? So, like I said, guys, those of you interested in joining my chemistry classes on a Saturday, I am in exam preparation mode for students who are writing in May 2021, right? So those of you interested, right, you can contact me at 868, right, 784-2059, right? And this is from Trinidad, guys. All right, so hope I'm able to do another video, right? So take care, guys.